Hello guys, welcome to our video. Group 4 presents water retention and air content determination. This test method covers the determination of the air content of hydraulic cement mortar. Our objective is to conduct a flow test of the mortar cement and determine the air content. The purpose of this test method is to determine whether or not the hydraulic cement under test meets the air-entraining or non-air-entraining requirements of the applicable hydraulic cement specification for which the test is being made. For the apparatus, we are going to be needing the flow table, flow mold, caliper, measure, mixer, bowl, and paddle, weights and weighing devices, glass graduates, tamper, tapping stick, spoon, and straight edge. First of all, the proportion of the sand mortar using 350 gram cement to 1,400 grams 20 to 30 standard sand and sufficient water to give a flow of 87.5 plus or minus 7.5% when determined in accordance with the flow determination. Mix the mortar in accordance with the practice C305, which is mixing procedures for mortars. Next, determine the flow of mortar mix. Carefully wipe the flow table dry to remove any moisture. Place the flow mold at the center of the flow table. Using a spoon, spread a layer of mortar approximately 25 mm thick inside the mold. Tamp the mortar layer 20 times with tamper, applying just enough pressure to ensure even filling of the mold. Overfill the mold by approximately 20 mm with mortar and tamp it as specified for the first layer. Cut off excess mortar to create a flat surface flush with the top of the mold. Lift the mold away from the mortar 1 minute after completing the mixing operation. Immediately drop the table 10 times in accordance with the specification C230 or C230M. Measure the flow by determining the result increase in average diameter of the mortar mass using calipers. Determine the mass per 400 ml of mortar immediately after finding the water quantity that produces a flow of 87.5 plus or minus 7.5%. If there is a lack of equipment, an alternative way can be done. Find an available container that can be used. Measure a specific amount of water, about 400 ml. If the available container cannot hold 400 ml of water, measure an amount where a ratio can be easily determined. Do not forget to mark the boundary. By using the mortar remaining in the mixing bowl, fill the container up to the line. Place mortar gently into the measure in 3 equal layers using a spoon. Tamp each layer 20 times around the inner surface of the measure. Tamp each layer in 1 complete revolution with sufficient pressure to fill the measure and eliminate voids. For our computation, we're going to be using 2 formulas, one for the slump flow percent and the other, the air content volume percent, where we got 93.75% for the slump flow and 10.54% for the air content volume percentage. The air content of the mortar sample tested was found to be 10.54%, determined through the volumetric method according to ASTM C185. In the case of Portland cement mortar utilized for masonry applications, it is recommended that the air content does not exceed 8%. The air content obtained in this sample significantly surpasses the recommended range, which can lead to various issues. Exceeding the recommended air content limit can produce several potential problems that may compromise the structural integrity and durability of the masonry. These issues include reduced strength, decreased workability, increased porosity, and poor adhesion. It is also believed that the excessive air content may be attributed to the water-cement ratio utilized during testing, which was adjusted to reach 87.5% plus or minus 7.5%, as well as the mixing technique employed in preparing the mortar. These factors have a significant impact on the air content percentage present in the mortar mix.